Next up, for what values of t is the curve concave upward? Our curve is x equals t squared plus 1, y equals e to the t minus 1. Remember what it means to be concave upward. That means that the second derivative d2y dx2 is positive. Remember also that we have a formula. d2y dx2 in this context is the derivative with respect to t, so d dt, of dy dx divided by dx dt. With this in mind, I'd like for you to go ahead and finish this problem. Find out what t intervals associate with the curve being concave upward. Let's see how we did. Since x is equal to t squared plus 1, dx dt is 2t. Since y is equal to e to the t minus 1, dy dt equals e to the t. So dy dx is equal to e to the t divided by 2t. Pretty straightforward there. Now what we need is the derivative with respect to t of e to the t over 2t for our second derivative. That's going to require the quotient rule, the result of which is going to be e to the t times the quantity of t minus 1 divided by 2t squared. Notice one factor of 2 divided out. So d2y dx2 is equal to e to the t times the quantity of t minus 1 divided by 4t cubed. We combined the denominators. Now we wanted to know when what values of t corresponded to concave upward. So looking where the numerator and denominator are 0 in the expression for the second derivative, I'm able to define intervals on the number line, and what we have is, well, e to the t will never be 0, so we don't ever worry about that in a situation like this. The factor in the numerator of t minus 1 associates with the number 1, and then in the denominator we have 4t cubed, and so we're concerned with 0 as well. So we're looking at intervals that are defined by t equals 0 and t equals 1. To the left of t equals 0, I used a test point of t equals negative 5, and I see that we have a positive second derivative, so concave up. When t is equal to 1/2, a negative second derivative, and so concave down. And when t is equal to 5, a positive second derivative, and so concave up. Double checking the statement of the problem here. Find values of t where the curve is concave upward. We want the ones where t evaluated to give us a positive second derivative. And so we're looking at values to the left of 0 and values to the right of 1. So our graph is concave upward on the interval from negative infinity to 0 together with the interval from 1 to infinity. Using GeoGebra again, I have plotted the curve t squared plus 1 e to the t minus 1. And what I see is something that's y isn't a function of x. That's okay. It's parametrically defined. But we're supposed to have intervals of negative infinity to 0 and then 1 to infinity. Here's the thing. Those are for t values. There's a little portion here between about 1 and 2 where the curve is, it's concave up from where it intersects the y-axis down below all the way to infinity there. It's concave up. What I was thinking about, though, was there's this little portion just around 1, above 1, where this curve is concave down. And then for the rest of it, it's very subtle, but it's concave up. So this little portion here corresponds to concave down, and that corresponds to values of t between 0 and 1.